For this, if we want to determine what a graph does for large values of x, that is, coming from the very start going to the very end, from negative infinity to infinity, using some more calculus-flavored language, we have wording like this. It's a little bit clunky looking, but really the easiest way to understand this is being able to see it pictographically as we're going through. Where if we have something of degree n and n is odd, then we say it is going to be falling to the left, that is, on the left side for values of x tending towards negative infinity, it's going down, while it will be rising to the right when the leading coefficient is positive. If we have an odd degree and the leading coefficient is negative, then we're kind of flipping the whole thing over, thinking in terms of transformations. So it's going to be rising for negative values of x. That means it's going to be coming up to the left, and it will be falling down to the right. Meanwhile, if we have that n is even, then we have stuff a bit more like our parabolas, where if it is even and the leading coefficient an is positive, then both sides will be rising. It'll be rising both to the left and right. And then if an is negative, then both sides are coming down. Where, again, when we're talking about this sort of thing, yes, there's more that's going on in the middle there. Any number of things can happen in terms of those turns, those relative extreme values, but what we're looking at is just the edges, which is always determined by that leading coefficient and the degree, in the same way that the value for a determined whether or not the parabola opened down or opened up. For a more general polynomial, the leading term an does exactly the same thing for fundamentally the same reasons. So let's get an example here to see how this works. For this example, we're going to use the leading coefficient test to determine the end behavior of the function x to the fourth minus 4x squared. So here we want to use the leading coefficient test. That means we need to identify what n is. Here n is equal to 4, and then an, which here would be a4, is equal to 1. We call it a4 because that's the term attached to the value with n equals 4. You can just say it's the leading coefficient if you don't want to be too picky about that particular part. With this, it's kind of hidden in there, but a3, a1, and a0 would all be 0 here. You can throw a whole bunch of extra terms in there if you really wanted to, but most people wouldn't. Anyway, we have those two values there. So we have even degree, and we have a positive leading coefficient. So we are in this case here, which means that the function will end up rising. It's close enough to a g for me, to both left and right. It is rising from the left and rising on the right, where if we wanted to be sure about this, we could actually graph it and get a picture something like this for our quartic function there, like so, where we can see that yes, it is coming up on both sides, as we would expect a even polynomial to do when the leading coefficient is positive. So that's a lot on general behavior. One of the big things that we saw coming up to this, one of the big things we looked at when we were talking about other polynomials as quadratics and linear terms, was looking at the intercepts, looking at the zeros. And we're going to talk about that next in the context of these more general types of things.